All right, so let's talk about electrolytes. Electrolytes are compounds that, when they dissolve in water, they can be used to complete an electric circuit. Okay, so water by itself cannot conduct electricity. So unlike what you might actually think, water cannot conduct electricity. It needs to have some ions dissolved in the water to have any sort of electricity get conducted through it. Okay, so if you dissolve some salt in it, it will do it, and things like that. So we define how conductive a solution is using the electrical conductivity, which is lowercase sigma. We will not do that in this course. If you take material science, you will do that at length over there. If you take when you take physics, you will talk about that in E&M. But not in this course. But just basically, you should know that generally, not true, but not always true. If you dissolve salt in water, you become more conductive to a degree. It's not necessarily a linear increase. But just know this: if electrolytes are dissolved in water, they will generally conduct electricity. Okay. Anything that partially dissociates is known as a weak electrolyte. Anything that does not dissociate at all is known as a non-electrolyte. Okay, so you can have strong electrolytes, non-electrolytes, weak electrolytes. And what we will do in this course is try to figure out and predict which of these three categories you will actually see. So I created this little map here. If I give you a question, a compound, and I want to know if it's a strong or weak or non-electrolyte, follow this mapping and you will always get this right, okay? If I have an ionic compound, go figure out if it's a soluble salt or a non-soluble salt. If it's a soluble salt, strong electrolyte, okay? So any of those things that we've done already. If it dissolves, it will be a strong electrolyte. It will dissolve fully. If it does not dissolve and it precipitates, it's going to be not an electrolyte. It doesn't dissolve. It can't do anything. It's just going to be sitting at the bottom, not doing anything. So it's going to be a non-electrolyte. Okay. If I give you a compound that's not ionic, molecular, you should figure out if it's an acid or base or not. If it's not an acid or base, not going to be an electrolyte. So what's that? Sugar. Sugar is not an acid and it's not a base and it's not ionic. That's not going to be an electrolyte. So if you put regular water that has nothing in it and you dissolve just sugar in it, it won't conduct electricity. Okay, it will be a non-electrolyte. Okay, if I look at my acids or bases though, I might get weak electrolytes or strong electrolytes depending on how weak or strong the acid is. If I have a weak acid, it will be a weak electrolyte. If I have a strong acid, it's going to be a strong electrolyte. Weak base, weak electrolyte. Strong base, strong electrolyte. So if you follow this mapping, you will always get this right. And let's look at some examples. I have, I don't know, like a dozen of them or something. So calcium hydroxide. Well, if I'm looking at this mapping, I'll go back to mapping. Compound is not ionic. It's going to be molecular here. It's an acid base. And it is a strong base. Therefore, it's going to be a strong electrolyte. You could look at it like that, or you could look at it. You could look at it as an ionic type thing, and you figure out that it's soluble. Solubles are going to be strong. So either way of looking at it is fine. HCl, the strong acid. Strong acids are going to be strong electrolytes as well. Okay. H2O. Well, H2O by itself, compound. Is it ionic? Nope. It's molecular. Is it an acid or base? Nope. It's a non-electrolyte. This is going to be non-electrolyte. This is what I mean. If water by itself, which is not tap water has stuff in it. They put stuff in it. And if they don't put stuff in it, it's going to get stuff in it as it comes across. Piping. It's gonna leach stuff off your pipes and have stuff in it anyway. What you need is deionized water, which we have in lab. And that will be non-electrolytic. Okay. Iron. Iron by itself, just iron. Well, iron is a compound, not ionic. It's molecular, non-acid or base, non-electrolyte. Again, non-electrolyte. Okay, it's not an ion. It won't form an ion, so it's not going to be electrolytic. NaCl. Okay, it is ionic. It is soluble. It's going to be a strong electrolyte. Okay, strong electrolyte. Okay, aluminum hydroxide. If you look at your solubility table, you will see that first of all, it's going to be here, ionic. It's going to be a non-soluble compound, and therefore it's going to be non-electrolyte. Okay, so this kind of reviews all the things that we've done. All right. Let's see. Copper nitrate. Well, all nitrates are soluble. Therefore, this is going to be soluble, and this is going to be a strong electrolyte. Okay. If I look at sodium carbonate, well, carbonates they tend not to be soluble. And this is not an exception. This is insoluble. Since it's insoluble, it's going to be a non-electrolyte. Silver iodide. It's another ionic compound that is insoluble. So it's going to be non-electrolyte. Okay? I don't know, lastly here would be here, acetic acid. Acetic acid is an acid. It's going to be a weak acid. So it's going to be a weak electrolyte. Okay, so I hope that makes sense. That's how you'd go about doing this. Okay, so as you can see, some of these things count both as an acid and base or as ionic, and they give you the same answer anyway. All right. So let's talk about titrations now in this next little segment.